All right, finishing up Unit 10 here, dealing with rational expressions again, but today operation we're working with is addition and subtraction. So addition and subtraction is the hardest because in order to add or subtract fractions, they have to have a common denominator. So we're going to have to multiply one or more of the fractions by something to create common denominators if they don't have the same denominator. Okay? So here again, same thing. We got to find restrictions, all that stuff. All right? So it says factor everything you can, find restrictions, right? Create a common denominator if you need one. Add the numerator. But remember, when we add fractions, the denominator doesn't change. So just add the numerator and then check to see if anything can be factored or divided out after you simplify, add all the stuff, okay? So in number 1, it says add each rational expression, state any restriction. So first thing, nothing can be factored, okay? And there's no variables in the denominator. So that means there's no restrictions. Okay. So in this case, 3/4 plus 5/8. In order to add these together, they have to have the same denominator. So we look and we figure out, well, we could make both of them an 8 pretty easily. So we can multiply this first one by 2/2 to make that 8 in the denominator. So that would make this 6/8 plus 5/8, right? And when we add fractions, we just add the top. So it would be 6 plus 5 over, denominator does not change. So 11/8. And we can't divide anything out of there, so it's just 11/8, okay? Now, number 2, okay? In number 2, everything's factored for us, so nothing to factor. We do have variables in the denominator, so we're going to work with restrictions. So x plus 4 cannot equal 0, so subtract your 4. So x cannot equal -4, okay? And then as we go through here, now we look, the denominators are already the same. They're both x plus 4. So we can go ahead and add these together. So we're going to take 2x minus 3 plus 4x minus 5 over x plus 4, right? Add the tops, keep the bottom the same. Now we just combine like terms. So 2x plus 4x is 6x. -3 minus 5 is -8 over x plus 4, okay? And then once we've added, right, we look to see if we can factor the numerator at all, which in this case we can a little bit. There's a GCF here of 2. So if we factor out a 2, we get 2 times 3x minus 4 over x plus 4, and there's nothing we can cancel out there. So that's it, we're done, okay? Now for number 3, if we look at number 3, nothing we can factor here. Okay, so if we look, restrictions 2y and 3y, right? Which both of those we divide, they're both going to give us y cannot be 0, okay? So as we work with these, we cannot add them together because 2y and 3y are not the same thing. So they need a common denominator. So they both already have a y, so that's good. We just need to make them have the same coefficient, the same number. So a number 2 and 3 go into is 6. So let's make both denominators a 6y. So to do that, we need to take this first fraction times 3 and this second fraction times 2, okay? So that's going to give us 2 times y minus 4 over 6y plus my bad. That should be a 3, not a 2. 3, so looking at the denominator, 3, and then over here, this would be 2 times y minus 6 over 6y. Okay, so now they have the same denominator, so we can add them together. So we're going to go 3 times y minus 4 plus 2 times y minus 6 over 6y. Okay, and then we just simplify the top. So distribute the 3, distribute the 2. So 3y minus 12 plus 2y minus 12 would be still all over 6y. Like terms, 3y plus 2y would be 5y. Negative 12 minus 12 would be negative 24 over 6y. And we can't factor that numerator, so there's our answer, right? That is what we're working with. And then our last addition one, 1 over u minus 2 plus 1 over u squared minus 4. So this one we can factor. This is a difference of squares. Okay, so this guy would be u plus 2, u minus 2. When we factor, right, we take the square root of those. So what we have, 1 over u minus 2 plus 1 over u plus 2, u minus 2. Okay, so restriction-wise, in the denominator, we've got a u plus 2 and a u minus 2. 2 u minus 2s, actually, but don't need it twice. So subtract your 2, add your 2. So u cannot be plus or minus 2, positive or negative 2. There's our restrictions. So now we need a common denominator in order to add these. So if we look at the denominators, that first denominator has a u minus 2. The second one has a u minus 2. The second one also has a u plus 2. So this guy also needs a u plus 2. So what we do is we multiply this guy by u plus 2 over u plus 2. So this gives us u plus 2 over u plus 2 times u minus 2 plus 1 over u plus 2, u minus 2. Okay, and again now they have the same denominator, so we can add the top. So we go u plus 2 and then plus 1 over u plus 2, u minus 2. Add those, so u plus 3. Ooh, it's bad handwriting, my bad. U plus 3 over u plus 2, u minus 2. Nothing to factor, nothing to cancel. So there's our answer. Okay? So that's what we're working with addition. So keep the top add the top, keep the bottom the same. Got to have a common denominator, all right? Subtraction, going to be very similar. Still have to have a common denominator. Only extra thing is when we subtract, we got to distribute that subtraction sign or that negative to that second fraction, okay? Still need common denominators, all that stuff. So if we look at these, subtract, state any restrictions. So nothing to factor. So if we look, we got variables down here. So for restrictions, we got to say s squared cannot be 0, and 4t squared cannot be 0. So to solve this, square root, s cannot be 0. And then divide by 4. And then take a square root. So t cannot be 0. So s can't be 0, t can't be 0. All right? Now to simplify this, okay, common denominator again. So if we look, first fraction is missing a 4t squared. So we've got to multiply this thing by 4t squared over 4t squared. Second fraction is missing an s squared. Okay? So we multiply, and we would get 16t squared over 4s squared t squared minus s squared over 4t squared s squared. Okay? And then now, since, again, they have the same denominator now we can go ahead and combine the top. So we go 16t squared minus s squared over 4s squared t squared. Okay? And then we just check to see if we can factor anything. Numerator, no. Or sorry, denominator, no. Numerator, this thing is a difference of squares. So we factor the top. 4t plus s, 4t minus s over 4s squared t squared. Can't cancel anything out. So that's what we're looking at. Okay? Now, number 2. Okay, nothing to factor here. No GCS, anything like that. So restrictions, we take those denominators, which they're the same thing. So we only need to do it once. Solve. So add 5. Divide by 2. So our restriction is that x cannot be 5 over 2. And then, again, denominators already the same, so we can go ahead and combine the top. So x plus 2 minus this whole thing. Okay, so this is where, again, this part comes into play that I highlighted at the top. Distribute the negative to the second fraction. Okay, so that's why I put it in parentheses, so we remember to distribute that negative sign. So it'd be minus 3x plus 2 over 2x minus 5. So combine like terms. We got negative 2x plus 4 over 2x minus 5. Okay. And then this has a GCF that we can take out of negative 2. So if we take out negative 2, that would change those signs. And then 2x minus 5 on the bottom. So that's what we're working with there. Okay? Sorry if you hear my dog snoring in the background. Let's see. Number 3, last one. So we got some factoring to do. The numerator, not a difference of squares, because this 3 is not a perfect square. So can't factor that. But in the denominator, we can use the big X. Multiplies the negative 18, adds to negative 3. Would be negative 6 and positive 3. So what we're dealing with would be 3x squared minus 1 over x minus 6, x plus 3 minus. Okay. So now we look restriction-wise. Sorry, it's way over here. We've got x minus 6 and x plus 3 in that denominator. So add your 6, subtract your 3. X cannot equal negative 3 or positive 6 for our restrictions. Okay? And then we can focus on combining these now. So if we look in the denominator of the first one, we've got an x plus 6, and then an x plus 6 in the second one. But we've got an x plus 3 here, but there's no x plus 3 over here. So we've got to multiply this one by x plus 3. Okay? So that's going to give us 3x squared minus 1. right? We're going to end up with that. So now they have the same denominator, so we can combine it into one fraction. So we go 3x squared minus 1 minus x plus 2 times x plus 3 over x minus 6, x plus 3, okay? And then we need to simplify the top, okay? So we simplify the top. Remember, there's multiplication between these two, so we've got a FOIL here, okay? So when we FOIL that, I'm just going to write it off to the side here to save a little bit of time. We would go x times x, x times 3, 2 times x, and then 2 times 3. So combine those. So when we multiply, we get x squared plus 5x plus 6. So the numerator minus, right? There's still parentheses there because we haven't distributed that negative sign yet. Okay? Over x minus 6, x plus 3. Now, we've got to distribute that negative. So we got 3x squared minus 1 minus x squared minus 5x minus 6 over x minus 6, x plus 3. Okay? So if we, like terms here, combine 3x squared minus x squared is 2x squared. And then we got minus 5x. Negative 1 minus 6 is negative 7 over x minus 6, x plus 3. Okay, so we've got that. And then, before we call it quits, we got to see if we can factor that numerator at all. Okay, so big X, but we got to use the swing method because this number right here is not a 1. So we got to multiply these. So that'd give us negative 14. Adds to negative 5 would be a negative 7 and a positive 2. So we can factor this. But again, since this is not a 1, we got to divide that out. So that would give us x minus 7 over 2, and then x plus 1 when we simplify that fraction. And we swing that, give us 2x minus 7, x plus 1. So our fraction, 2x minus 7, x plus 1, x minus 6, x plus 3. And unfortunately, we can't divide anything out. So there's our answer right there. Okay? So addition and subtraction are the harder ones because you need that common denominator. So practice with your homework. Let us know if you have any questions. All right?